Industries worldwide are facing a growing challenge: how to reduce energy consumption and lower carbon emissions. But what if there was a way to turn waste into opportunity? Enter Mechanical Vapor Recompression, or MVR, a game-changing technology that captures and reuses waste steam, revolutionizing industrial processes. MVR is transforming the way industries operate, slashing carbon emissions, cutting costs, and helping companies move closer to their net zero goals. At the forefront of this revolution is AERZEN, partnering with industries worldwide to implement innovative MVR solutions that are shaping the future of industrial efficiency. In this episode, we'll dive into how MVR is changing the game, paving the way for a greener, more sustainable future. We're joined by two industry leaders at AERZEN: Willi Peters, Head of Quotations and Technical Order Processing for Modified Products, and Eugen Peil, Team Lead Quotations for Modified Products. Join us as we explore the power of MVR and how it's shaping the next era of industrial transformation. The future of efficiency starts now.
Gentlemen, welcome. Thank you for being here today. Much appreciated. Let's get straight into it. Tell me about MVR. Give me an introduction to MVR.
Maybe we start a little earlier. Please, yes.
Yeah.
That's very interesting. You have to do an introduction first, maybe.
Yeah.
And it's very interesting that we visited yesterday the ADIPEC here in Abu Dhabi. And there was a really interesting question, and the people could stamp what they believe.
Okay.
And the question was, do you think a net zero economy by 2050 is achievable? Maybe you don't know what.
Yeah.
Do you have a guess?
Do I think it's achievable?
Yes.
2025 years. I'll say 2050 is achievable.
2050 is achievable. So the people weren't sure.
Oh.
So 50%. So they were not sure at all if it's really achievable.
Okay.
So we have to convince them that it is achievable.
Okay.
We have to find solutions and give them examples how we can achieve that.
Okay.
So this is our part where we come straight in. So we have solutions for the processes in the industry.
Yeah.
We have solutions, and one of the examples is the MVR. So this is very important. It's just one little example, one step to reach that kind of goal, because we have to reach that goal. This is the part.
Yeah.
So, and Eugen will tell us will answer your question. Yes, but the introduction is very important. MVR is just a first step.
Yeah.
A small step, but a very important step to change one process in the industry. So this is the reason why I started a little early.
Yeah, no, I like it, yeah.
Yes.
The main topic is, of course, that you have carbon capture.
Yes.
Carbon capture is the main topic. But, we are not that into with our products or with our thinking. So what we want to do is the indirect. Is it indirect?
Yeah.
So we want to do it indirect. So we are thinking about to change the industry process to a more efficient way.
Yeah.
And of course, for this you also have less carbon in the ambient. For this you also can save some carbon.
Yeah.
And so we are now focusing, or we challenge, and we see it many applications is the MVR application. MVR is mechanical vapor recompression. That means, for example, in your industry, in your process, mostly you need water to cool something down. For example, some power plants, and you see the white smoke is going out.
Yeah.
And this is steam. This is hot water steam. So, and they wasted this because we don't need it. Why? And the idea is because the steam has, of course, such an energy is to get it back to you because it's energy, and to save this and to recover it. And that's a mechanical vapor recompression. So it's a process where you generate steam, where you, of course, you have to put energy, you generate steam and use it again. And that's the main idea behind the mechanical vapor recompression.
How difficult is it? Like, the way you describe it, it sounds very like, oh yeah, you just capture it and then that's it.
Yeah.
But logistics-wise,
So logistics is not that wrong. It's not that the logistics is not that difficult from our point of view. You need a boiler, you need a machine, you need piping, and you need some heat exchangers, and that's it.
that's it.
That's it.
But why hasn't it been done before? If it's so simple, why do we need a 2025 or 2050 incentive? Why not just do it?
Of course, I think we will also come later to your answers. But of course, it's money.
Yeah.
Yeah, for of course to look on the one hand on the capex and the opex.
Yeah.
And for example, 4 or 5 years ago, this topic is like we are working in a headquarter and we are 50 subsidiaries all over the world. So we of course got inquiries or questions from the market, from our subsidiaries. And I don't know if you could, maybe I'm wrong, but that was not that topic.
Right.
Energy efficiency or saving energy, in Germany maybe, or in Europe, yes, but nevertheless in other areas, and not even in Germany, to be honest. But then, of course, everybody knows the political situation in Europe with the Ukraine war changed, and our energy prices rised up. I personally now pay the double for the energy.
Really?
4 years ago, I paid approximately for my private house, 20 cents per kilowatt hour. Nowadays, for this year, I paid 37, so nearly the double for my private house.
Wow.
And of course, it's not only my private challenge, it's also a challenge for the industry.
Yeah.
And of course, they say, okay, we of course need huge amount of energy. And of course, if also for them the prices are double, they're looking now, of course, for solutions where they can save energy.
And is this is the double result of the war, or was it like increasing anyhow?
That you have to ask the guys in Berlin, in Moscow, in Shannon or something like this. But of course, the feeling is yes, because we stopped, of course, as Europe, or I can speak now for Germany better. We stopped, for example, the cheap cars from the Russians.
Right. And from my point of view, I also would add to that the mindset of the people changed a little bit. Yeah. Fridays for Future. It didn't start because of the war. Yeah. So, but it was like a saying. They called us human to save energy, to save the environment, to be more, to change the cars into electrical cars. So the mindset of the people changed in the last couple of years, and so there's a lot of pressure. So the government thought, okay, if the people are going on the street to change the nature, to save the nature, so we have to do something. And the war is maybe it was more pressure, even more pressure because of the war. Yeah. So there was already a mindset change before. And now it comes that everybody thinks, hey, how can I save energy? How can I save the nature? So one of the reasons.
But I was going to ask though, do you think people would still are people still as motivated if they're paying double?
Like by the end of the day, nearly the whole world is working with money and for money.
Yeah.
So of course that's this kind of price raisure, of course, puts pressure to the people, to the industry. So I think yes, that's maybe one of the key factor that we are now, of course, of the price. We are pushing more to save the energy, and of course, it's a good benefit with that we all want to have, because I think namely everybody is a father, is a mother, so we have to think about our kids, to think about about their future, not our future anymore.
Yeah.
And of course, that is.
And we are beginning to be creative. And I love this kind of pressure. It's also, pressure is sometimes bad and sometimes very good. Yeah. And I love this kind of pressure because now we are thinking. We are thinking about the solution, MVR. You said something, hey, why didn't we do that in the past? The technique was there. So we could have started already like 20 years ago, 30 years ago, no problem. But nobody was, we needed this mind change. We needed some crisis, what we have here, a lot of water crisis, and that's changed our mind a little bit. So this kind of pressure is put also in the industry, and they start to rethink the processes. Yeah, MVR is now becoming a very interesting process to change the industry, like one small part of the industry. Yeah, of course.
But do you think is it easier than people thought before? Now that it's being done, are people like, oh, it's not that difficult? Or is it a case of people doing it and kind of going, oh, yeah, by 2050 we'll have it done?
Yeah.
Like,
that's a good question. Yeah. I really think that in my environment, my personal environment, more people think of it. And since, for example, the diesel is not wanted anymore, maybe you've heard about it. Yeah. And everybody's pushed economically to the e-car. So the people think, okay, for a city car, my e-car would be maybe a possibility, a good possibility to have it. So, and even if I have on my roof PVR, I can charge my e-car, so it's not a problem. So in my environment, people rethink, maybe their mindset change, and also the economy is not delivering. It's like the pressure from the government, the regulations push us also in addition into that direction.
Yeah.
So this is two. I would say there are two things: my personal change and the pushing the regulations that the government give us.
What's the pushback though? Because from my side is, not from my side, but one of the things I hear people go, I'd love to go and get an electric car, but it's too expensive.
Yep.
Where do I charge my electric car? I can't charge my electric car. I want to go for a long drive. I can't. And then I find people kind of like almost reverting a little bit. Like it's like they tried, but because they haven't been pushed, they kind of go, I tried it, I'll go back to petrol. It's easier for me because my Fiat 500 will last longer, I'll drive further.
Of course.
You know?
Very good. And I would say, yes, there are a lot of challenges with the e-car still. A lot of challenges. My personal, if I love to go with my caravan, is it possible to go where do I charge it? If I go, how far can I go? How fast is the battery emptying when I when I have a heavy load in the back? So there are a lot of challenges which the government has and the industries together has to solve. That everybody gets comfortable with that. So the circumstances has to be changed still. There are a lot of obstacles why many people think for the city is great, but but I'm not just living in the city.
The day-to-day life, I think it was tricky. Because I know in Dubai is different. Dubai is Dubai and there's no real country. But I know when they first brought electric cars in, they automatically got free parking.
The same with
The government went, okay, well, if I electric car, we'll give you free parking. And then it was like, and then if you come to the malls, you charge your car. I was like, okay. And then if you buy a new villa, you'll get an automatic charging station. Whereas I would just worry about the older countries like Europe. It's just the government doesn't do enough for the middleman to
absolutely,
the incentives. But they penalize. It's like you get penalized for having a 4x4. But it's cheaper to have the 4x4 than is the electric car.
Of course.
It's kind of like, you're going back and forth.
Yes. And what about if you live in Cologne? No problem. Or in Dubai. Everything is very close by. The shop is close. But what if you live in the country? So there has to be a lot of solutions also for that kind of people. I'm personally driving 45 minutes to my work.
Okay.
And I can't charge it there somewhere. So what can I do? I don't have the option to change. The public transportation is not an option. So I would need like 3 hours a day just to go to work. Just to get there. So it's really, there are a lot of regulations, a lot of circumstances which has to be changed by the government with the industry together. So this is a big topic, still. And I'm always also thinking, okay, do I need a car? Can I afford a car? But I say the economy is giving us now, not the German cars maybe. They are still quite expensive, but from the rest of the world, there are coming electric cars which are a little cheaper.
I feel, I know sometimes China gets a bad reputation, for example, but when they do get involved, the price is lower.
Absolutely. Of course.
Like their electric cars are impressive. Like they're not the old school like what we know, like Audi, Volkswagen, Ford. But a Tesla is still quite expensive. Like if you're to buy Tesla, and you have a choice between Tesla, and you go, but the Audi's nice.
Yes.
But then China comes along and goes, listen, we'll give you an electric car that looks like an Audi and half the price.
And for Germans, it's even more difficult. They don't think that Tesla is a car. So we are spoiled with Mercedes, with BMW, with Please. So a mindset also has to change in our. How can somebody else in the world build cars except the Germans?
But that's what you do it well. Your cars are. I'll be honest. You have a explain to me the working principle. So how does MVR process work in terms of energy recovery? And if you can break down the steps and comparison, that kind of stuff, that'd be great.
Okay, to understand what is happening in this kind of MVR application is, we have also to go a little bit back, step back for, let's imagine we are back at school, so we are learning.
Yeah.
What happens? For example, you see this kind of MVR application nearly every day in your kitchen. When you cook your pasta or something, or you cook your boiling your eggs in the morning or something like this.
Yeah.
So MVR is you want to split two substances. So for example, you have water and salt.
Yeah.
So it's salt water or seawater, what else? If you boil this water, so it becomes 100 degree. We know water is starting boiling at 100 degree now at the normal ambient condition. So the water starts boiling, getting steam, and goes away. So by the end of the day in the boiler, you only have left salt.
Yeah.
So, for example, if you are at the Himalaya, so you are in the mountains for hiking and so on, and you are at the Himalaya, to our highest mountain in the world, approximately, I don't know, 8,000 meters?
Yeah.
Something like this, 7, 8. Yeah. So if you're there, in the morning you wake up in your tent when you want to boil the egg. And you have a can, you put water, you put your egg, you put fire or something. The water will start boiling at approximately 70 degree. Why? Because the ambient pressure, if you get on a higher level on the Earth, the ambient pressure is lower. So now approximately 1 bar ambient pressure, and on the Himalaya you have, well, for example, 700 millibars, so
Yeah.
30% less. So the boiling of the water starts earlier, and it starts earlier. So the water becomes to steam 30 degrees earlier than, for example, on the normal condition in Dubai or Germany or else.
Yeah.
So not on the high levels, high sea level. And exactly that idea, this is the MVR. So what happens is, for example, we take a boiler. We have a boiler, for example, with, I don't know, let's still take the example, water and salt. So of course you can bring the energy because you want to separate salt and water. You can bring energy and like 100 degree and everything is gone and so on. So then you have, of course, an energy consumption.
Yeah.
For example, 100 kilowatt, for example. What happens is now, and this is the idea behind MVR, is you take the boiler, you close it. So you have a closed system. And then you have kind of pipe or something like this. Then you suck air outside this can. So what's happened? You create under pressure.
Okay.
So the pressure inside the boiler is lower than the ambient pressure.
Yeah.
So like in the Mount Everest. So the pressure in the can is lower. That means that this process of boiling of water will start earlier. So you have to bring less energy to the can. Now, for example, like on the Mount Everest, only up to 70 degrees.
Okay.
And this boiling process is started. So water will evaporate, and then you get your salt. So of course you save the first energy, because you don't need now to heat up the water up to 100.
Yeah.
Only 70.
Yeah.
But of course, and that's a second step is to create this kind of under pressure. You also need energy, because under pressure doesn't happen like this. So you have a machine which tuck the air outside this can or this boiler or something like this. And now, of course, and this what, for example, what I said at the beginning, the plants, the power plant, something like this, you can throw away the steam. So, but you don't do it. And that is the vapor recompression. You take this steam,
Yeah.
which is going out to the machine because you suck it off. So we have 70 degree in the boiler. It starts boiling, the water becoming steel. And you take this the steam and you recompress it. For example, only on a higher energy amount. So for example, to 80 degrees or something like this. Only 10 degrees more, because it's 70 to 80. And then this 80 degree you bring back to the boiler. And you will heat up the boiler again. That the boiler should still be 70 degrees.
So you have a circular.
Yep.
Yeah.
Like a loop.
Of course, for the starting phase, you need an external energy.
Yeah.
Because you need first to heat it up to 70 degrees. That the boiling process is starting. But when the boiling process is started after 5, 6, 7 minutes, I don't know, depends of course of the size. And then you creating steam, and you recompress the steam and bring it back to heat up the boiler. Then you can switch off the external energy. And so it's like a recompression. So only the process is only needed one machine who creates this under pressure and brings the steam back to the boiler. And that's a circle.
And then you can do this on obviously a very small scale, but then how large a scale can you go? Could you do this, for example, on a cruise ship? Could you use
We are Germans who do it in our breweries. And I don't need to tell you how much steam we bring. So this kind of boilers, you can, I don't know, be 4 or 5 people can nearly play some football inside.
really?
Yeah, of course. It's industrial industry.
Yeah.
It's not your private industry. So of course, this kind of boilers, they are huge.
And then is it? Where do you envision it going? Where would you like to see it being implemented? In the sense of, would you like seeing it like for industrial factories, or do you want to see it in domestic use, or?
No, it's industrial. Maybe we can share some more application where we can use it.
Yeah.
So I think this was a very good explanation that we can save energy, and there are a lot of industries where we can use it. So, for example, it's the evaporation and the concentration of liquid. Everywhere where we have liquid, we can concentrate that, or we can evaporate that.
Yeah.
So, for example, a farmer in Munich or wherever,
Bavaria.
or Bavaria, yes, around Munich, not in Munich. Yes, of course, you're right. Thanks. He is producing milk, and this milk he wants to sell it to a different country, to the US, because they love the German milk. Just for example.
Yeah.
And this milk is not, won't be shipped in liquid. So they evaporate it into powder, and they will send the powder to the US because it's much cheaper. The transportation is much cheaper. So, and there they will add water again, and then you have your milk.
Yeah.
So in the food industries and in the beverage industry, there are a lot of possibilities to use this mechanical vapor recompression. So that's very interesting. This was one example. Or you can have the fruit juices. Okay, away. And when we go to Coca-Cola, to McDonald's and drink Coca-Cola, that's what I meant. Sorry. It's did you notice that it's not Coca-Cola? There's many times it comes water and I relate the water and tires. Yeah, exactly.
Coca-Cola is also shipping only concentrate because it don't make sense to ship the whole normal Coca-Cola. So because water, everybody can nearly put the water in this product which he needs.
Yeah. One more example. So this was the food and the beverage industries, which is huge. Just example, India, 1.5 billion people. So they have a huge food and beverage industry. They need that, but every country in the world needs that. So it's a huge possibility, a huge chance, what we can, a potential, I would say, for saving energy. Or the seawater desalination. We all know that water is a huge problem in the world. The people leave their countries because they don't have fresh water.
Yeah.
So, and we have a lot of seawater. And the desalination happens like this, the same example, the same process, that the fresh water is, they evaporate the salt and the water. So they have fresh water, and they have also the salt, which they can sell.
Okay.
So this is another huge possibility what we have. And all animals, we need this for the animals, for the people, for the whole environment, the trees. We all need fresh water.
Yeah.
So it's a huge potential again on this kind of application. So these are just some examples where it can be used.
For example, I personally was involved in this project in Germany. I don't know, how you wash your car in Dubai? Do you go to a wash street, or how you wash your car?
Here would be power hoses and the machines.
Yeah.
Okay.
The same in Germany, yeah.
I say exactly in Germany. So in Germany you have like a garage or something like this. I don't know how to describe. You go with the car. You pay, I don't know, €1, then you get a jeton, and you put the jeton in, and then you get a pipe or something that can clean your water. So this wash park, or how you say it, of course have wastewater, because the water is going to the ground.
Yeah.
He has to collect it, and this is wastewater. Of course, it's in Germany by law. You are not allowed to throw it away to the river or to the sea or something. You have to clean the air. So that's why we have wastewater treatment plants, of course. Even though every house, of course, is going, the wastewater is going to wastewater treatment plant.
Yeah.
But in person, in our private house, that is municipal. So because it's everything nature, what's happened there. But if you wash your car, it becomes the wastewater is industrial wastewater, because there's always a little bit of petrol, some plastic,
Oil.
yeah, and so on from the tires. That's not natural anymore. So that's industrial. And so of course the wastewater treatment plants charge you a lot of money that they clean your water. For example, like it's nearly 3 or 4 times the price like the municipal, so like the private one. So what happens is, for example, only for let's calculate. It's the wash park has, I don't know, for example, 100 liters, and he has to pay €1 that the wastewater treatment plant will clean his water and bring it down to the river and the bad things out. So what can he do with this 100 liters? He can also do the same thing, evaporate. So he will take out the fresh water out.
Yeah.
For example, let's say 80%, and then he has 80% of water is going.
Yeah.
And he has only 20%. Of course, this 20% are high concentrated, because you high up the concentration of this of everything.
Yeah.
But then, but at the end of the day, he only has bring 20 liters to the wastewater treatment plants, because they don't see the concentrate. This doesn't matter.
And you can reuse what the 80% back into the washing machine or the
For example, also you don't need to throw away. He can have the water, but he evaporate, and he only now brings the 20 liters to the wastewater treatment plant. And now, of course, he has to pay per liter. He pay only 20 liters, and not 100 liter anymore. So it's also for him very interesting to evaporate the wastewater. And of course, it makes sense if you have to evaporate to use a mechanical vapor recompression system.
Interesting. Can it be downsized? Is it sizable where the household can use it?
I think to go to the private,
It's not worth it.
what am I talking about? The mechanical vapor recompression?
Well, for example, like if you're having a shower, or if you're cooking on your hoods, if you have your AC on, this kind of stuff, or
I don't make sense.
it's not worth it on a small scale.
No, it's also it must be, and to be honest, also of course the invest is of course higher than a normal project for normal industry. For example, let's take the example from Willi with the milk.
Yeah.
So with a farmer, you have a boiler and you have an external energy or something like this, and of course you have a higher capex, because now you will need you need piping, you need a machine who can create under pressure and so on. Of course, the capex is higher, but of course the return on invest is normally, and that depends, of course, how long you have to run the system.
Right.
If you, of course, have your production 24/7, then your return on invest will be, I think, very high.
Yeah.
And of course, in your private house, that 2 times or per day that somebody is showering, or 3 times a day that somebody is cooking something.
It just doesn't. But for the farmer, for example, what is his return on investment? Say the farmer goes, I want that.
Yeah.
Is the technology available for him to do it, or is it still too expensive for the farmer, or is it still industrial?
Exactly. That's, for example, like near the same with our biogas solutions, which we have in Germany, for example. Normally, the typical farmer, like cow farmer who producing milk, for him alone, it don't make sense.
Right.
And you typically have some milk industry where maybe 50-20 farmers bring their milk, and then they evaporate it.
Okay.
So no, for then it must be a huge farmer. So I don't know that in Germany we have such a huge farmer who can do it by his own. Normally they bring their milk to a milk industry, to somebody, and they will do it, because
like a central station, yes, somewhere they said, yeah. But is that because the technology is just so expensive, or is that where the issue is?
The technology is what is expensive? That's the question. What is expensive? I think everybody's talking for return on invest. And if because you are a farmer, you only need it maybe 1 times per week, and the 6 other days the whole invest will stand and don't work.
Yeah.
And and if you concentrate it, or make a centralization of it, then of course you can use it on Monday, you can use it on Tuesday, on Wednesday, and then of course it makes sense.
Yeah.
The system must run.
Yeah, it has to be fast. Yeah. So we have like an industry solution, yes, which is on a private version. It's hard to
to put it in the private person. Yes, we can do a lot. Sure, we can do a lot for the nature at our home. We can have a PVR, so like that's a lot of things, and we can have maybe walk more. But this solution, what we are talking about, is more mainly for the industries.
Yeah. And what is the cost of this technology? Like is it a new technology that's expensive, or is it technology that's been here a long time, but just
The technology itself is not new. We have some processes or some projects that were 30, 40 years old.
oh really?
Yes, of course. That's nothing. That's boiling water or
Yeah.
boiling liquid. That's that people 6,000 years ago do this.
Yeah.
So the evaporation of liquid. So that's nothing special. And the idea also it's not that special. And some people use it, for example, in the past more, to get a better product, for example, to make a higher concentration, for example, of your apple juice or whatever.
Yeah.
Or for beer Germans, like I said, beer.
Yeah.
So it's the same, that you evaporate some water and that you get a higher amount of alcohol in your glass of beer. That was the idea, not like to save the energy.
Yeah.
Or energy saving like this. So the idea behind this is older than us.
When you speak about the price, as Eugen said, it's hard to say because we have like a lot of different products. So we will find the solution for each industries,
Right.
and they are just the amount in the beginning is maybe not the biggest issue when they know how much money they can save.
Right.
So and that's the solution we are finding. We are trying to find when we have that kind of process. So we are looking at the idea of the key facts. 24 hours. It's very important how he's running his process, how he's running his system. So and then we calculate together. Okay, the return on invest, you can save up 30%, 40%. It really depends. We can't say that like right away. We have examples where the people came to us or where we sold something and they say, hey, we saved so much money. The return on invest was less than 2 years. So it absolutely makes sense. And this is why the industry has to see the price and the process behind it, not just the price in the beginning.
Yeah.
So the price can be, just for example, can be really high, and everybody of us would say, whoa, this is a high price. And they would say, no, it's not a high price. I know what I will get out.
Yeah.
So the capex is high for some industries, but they know about that. And we have a calculation for them. Together with them, we will calculate, and then they will say, okay, high price, short return on invest, no problem.
Yeah.
So, and this is the situation which we are facing, where we are going. So but we are going it for each solution step by step. It's a solution for each company, each industry.
Yeah, and I also want to add, as for example, in Germany, you get in Germany you get kind of a CO2 certification.
Okay.
So if your industry or your company is using less energy, so not only the money you can save, so of course one benefit, but also that you don't you can buy the certificates and you get from the government some money paid or something like this. It's other side. So the CO2 reduction.
And we went to India, for example, a couple of weeks ago, and that was very interesting. The government is supporting that idea. So I'm not sure how much they get, or if they have to pay penalty. I'm not really sure, but the government supports it, put pressure to put it into the industry.
Yeah.
So they don't have a choice. So they have to do it. But as we said in the beginning, pressure sometimes it's good, and sometimes it's bad. Too much pressure is bad, but a good pressure, pushes the industry also in a good direction to save energy. And sometimes we have to convince them, yes, to show it, and we have to show examples.
What would be a pushback though from like the governments? What would be their pushback or industries? What's the most common thing you hear when you bring to the table? What's their
saving of energy.
Yeah.
And of course, saving of energy, saving of CO2, reduction of CO2.
No, but for example, say you come to me.
Yeah.
What would be the industry's pushback? Where they go, no, actually, I'm not sure, or maybe, or I'm happy.
No, I get it.
I'm happy the way we are, or
maybe the price.
The price.
Maybe the price.
Maybe the price, and they would say, I don't want to pay this money in the beginning. I'm not really convinced that it's working because it worked in the past like this already, and maybe in some countries energy is not that expensive still.
Yeah.
In some countries it is like that.
Yeah.
In most of the European countries it's getting more expensive, but some countries they don't care. So then they say, why should I invest money? Because it's cheap.
And also, for example, if you have a factory, for example, so in a brownfield project for us, so you have to revamp it. Sometimes it's only some silly things, but for example, I don't have the space in my room.
Yeah.
Because there are pipes, I need the machine and so on. I need to maybe make the new room ventilation. I don't have the space. So it's not possible for me. Of course, on a green field, we make a whole new building, then everybody's open to, okay, we can do it meter longer, meter wider, what else. But sometimes you got companies, they are still 60, 70, 80 years old. So the walls on the in the industries, in the company, and of course, and there's no possibility to install this solution.
Is it
Unfortunately,
it's a technology, not technology, but is it are businesses more inclined to incorporate the technology from the beginning as opposed to revamping something that's old?
it depends, of course. I think that nowadays it's even if it's not make that sense that, but revamp is more because we don't build that much new factories. Even in Germany, I don't know about what how it's in Dubai or something like this. But so revamping is of course getting is nowadays higher amount
Yeah.
because of course they are the price is rising and they have to act now.
Yeah.
And not when they build the factory in 5 years.
Yeah.
So they have to act now.
The market for revamping is of course much higher. Yes.
Yeah.
So they have to do that, and sure they have to be pushed a little bit. Everybody has to be convinced. Again, a mindset change, the personal, private one, also from the industries has to change as a little bit. And we are talking about prices, and I know this is economically the most important thing. We all have, as an industry, we have to earn money.
Yeah.
But we have to think and answer one question: is it somehow also a duty for us? Beside the price, if we can do something to save energy, shouldn't we do it? Yeah. Maybe the return on invest is not as a normal standard economic that it has to be less than 2 years or a little bit more. So we have to answer that question.
Yeah.
In each country, in each region, everybody has to answer that question. Can I do that? Should I do that? Isn't it somehow a duty to do that, regardless of the price? Sure, we have to earn money. I know that. And this is the first goal. Otherwise, we can't pay anybody else. And the economy is decreasing. I know that all. But we have to answer that question also.
How is it in regards to the Gulf, like UAE or Saudi? How have they incorporated it? Are they on board with it, or is there?
To be honest, from this market in this kind of application, I didn't get that much, or to be honest, nothing on my desk yet.
Okay.
No,
Interesting.
nothing on my desk.
But this doesn't mean that there is no market. There are a lot of players like we are.
No.
And maybe some other companies which are more located here, have more influence on the industry, are doing that kind of things. That's no problem. And we know we have a lot of companies to do the same thing. So no problem for us. And this doesn't mean, even if we say that we don't know it exactly, how much will be like invest in that kind of process change.
Yeah.
But I know that they will do that, and they just have a new goal, as I said, 2050, net zero. And this is one smart step, one small step into that direction. So even if it's not now for us for our company, I'm very sure that they do that. And I'm very sure that because of this goal which they just set up, I was reading it in the newspaper that they have like a new goal of 2050.
Yeah.
I think that will change again. They will start pushing it again into that direction. Every country has to start one day. So in India, they started already a couple of years ago. In Germany, they started now. But even in Germany, we have industries who are conservative in that kind of thing, yes. And they think twice, we say, if we should invest. So,
But does the government get involved then? Does the government say, no, you all have to do it?
yes.
Like in Germany or in Europe, is it?
Yeah, the government doesn't say, of course, you have to implement MVR. That's not possible because this kind of solution is, of course, in the car industry you don't need it.
Right.
For
Okay.
example, that's right. What they do, of course, is to do it on a higher level. For example, okay, you have to reduce your emission by 10%, by 5%, and how you do it's your problem.
Yeah.
So that's what they're doing. Of course, the government cannot say you have to produce your car like this, you have to do your milk like this, you have to do your shoes like this. It's not possible.
But then does it not kind of kick in then, like where they go, well, it's better for us because their water is being reused and all the emissions are being like, why would it not be more enforced? Would it not make more sense to enforce it as opposed to kind of saying,
But for example, how we will do it? If I think there's a huge industry, I don't know, a huge plant for energy or what else. There are so many possibilities to save energy,
yeah,
and maybe this kind, the industry itself, the company itself says, okay, I can do it, but then I will lower my CO2 emission by 0.2% only.
yeah,
They're such a big company. But if I do maybe the other thing, I don't know what, for example, I can save 5%. So of course they are more interested on low hanging fruits.
yeah, yeah,
So that depends, of course, what company you are,
yeah.
what is your main product, what are your processes and so on. So it's not easy to say do it. It's good. It's
Did you find India more open? Were they open to it?
We met, we were 3-4 weeks ago there, and we met somebody who was also working with this mechanical vapor recompressions systems and applications. And he told us, he was middle of 50 something, he was in this business for 20-25 years, and he has an own company and everything else, also dealing with it. And he said, when I started, I had a vision. I had a vision that his vision was, he said, I want to eliminate all the boilers in the India industry.
Well,
You won't go away from this alternative or the old one where you boil oil is a liquid. What else? So you're going to mechanical vapor recompression. So he was dreaming of it to get rid of in this industry.
wow.
So we met a certain company. This doesn't represent all the industries in India. So, but they were really on fire with that. Yeah, and they increase their amount, their value, their order income on a huge way. So this company was really on fire to do that. But this doesn't represent India. So we met them. So
Yeah.
we know that's a huge business, and India is very hard into that.
Yeah.
We really love that, yes, and we like that. Yeah, as I said, the mindset maybe there is a little faster than somewhere else. That's what just our opinion. That's what our feelings. We can't measure that. We don't have key facts for that.
Sure.
No key data. Yes,
Get that.
this is just our impression of visiting different countries. So this is what we have to.
Because this probably leads on to my next one here. The cost effectiveness. So I think we kind of touched on it, but
Yeah.
if you compare this to traditional systems, both in terms of initial investment and long-term operational savings, obviously long-term is better.
Of course.
But is the initial investment, do you think that's what's scaring people?
It could.
Because
You know, how is just such a job working? We get, for example, a inquiry if somebody is interested. I am interested in kind of system. Okay, what do you have? Because we got in touch with the customer. What do you need? How big is your boiler? Which temperatures you have? We check everything. We say, okay, for example, for you, this is the right solution. I don't know, for example, 100,000 euro. Only to say a number. And then, of course, he saying, thank you very much. Okay, I'm going home. I will calculate, because they calculate. Everybody wants to earn money. And he calculate, for example, okay, I can save this amount of money, and by my production is only working 5 days per day, because I'm a small brewery or something like this. And they say, hey, my return on investment will be 13 years. Of course he will say no. Of course he will say no. And the other guy, who you talked last week, nearly the same application, but he's driving this, I don't know, 24/7. And he said, okay, also, for example, 100,000, and he will calculate, but can I save for my process? And so on. Oh, my return was at 2.2 years.
yeah,
So that's the game. That's
yeah, big difference. It is different. It's a big difference.
So that's why it's every project, every contact to the customer, every talking it's difficult.
Yeah.
It's difficult and it's completely other because the one says, hey, I'm interested in it, but I want to use it only a little bit. And sometimes they say, to be honest,
It's not worth it.
don't do it.
Yeah.
Even if I can sell my product, but to be honest, don't do it.
Yeah. How long is the process it takes you from start to finish? How long quickly can you tell them, like,
If I have all the data which is necessary for me, approximately 2 days.
really?
Yeah, it's a calculation.
Yeah.
We have a calculation sheet. We can calculate what energy he can save. Of course, he then has to say what he pay for the energy because I don't know. But I can say, hey, this is the energy saving. I don't know, 1,000 kilowatt per hour.
Yeah.
And he say, okay, I pay, I don't know, 1 cent. So it's the return on invest. It's not that good. But if you pay, I don't know, 30 cents, then of course the saving of money for him it's very good. So his return on invest is faster. So we can provide the solution. Okay, that is capex for the solution, and this is the energy saving. And of course, the last step must be done by the customer.
Is there government incentives for it? Like, is there tax incentives or government incentive, like, if it's implemented?
I know they support some other industries to change their process, but I'm not quite sure if they also have in mind to pay something in this mechanical vapor recompression. I really don't know.
I only know the high level. So if you save CO2, you can get some money back, but it's CO2 saving. It's not like, okay, do mechanical vapor recompression system in your process and we will pay you, I don't know, 1,000 euro per month. I don't know.
Yeah.
I didn't hear about it.
In Germany,
So
the government supports to change the watering pump. Eugen, we were reading about that. And this is a different process again, but not vapor recompression. So sometimes they do that, but I really I have to be honest, I don't know it.
I haven't heard it. Yes. It'd be interesting.
Yeah, it would be.
Can MVR systems be integrated with renewable energy sources, such as solar or wind, to further reduce energy consumption? And if so, how?
of course, not directly, but because you need a process of evaporation. So like we don't liquid. But what is, of course, this kind of machine who creates the under pressure and then compress the steam again to the boiler. It's driven by an electrical motor. And of course, what is possible to drive the electrical motor by solar, by wind energy and so on. This is a possibility of it.
Yeah.
So of course, if you are that good, you reduce your energy inside because it's mechanical vapor recompression, and then your driving electric motor, which has to be driven, is driven by the sun or by the wind. So of course, it will, I think, win-win situation.
Yeah. So ideally, like, on paper, the Gulf region or Africa region should be, for solar and wind, it should be better.
Oh, of course,
On paper.
yeah, on paper, yeah.
If they do it. Yeah.
But of course, but then again, please imagine you are the customer. So first, of course, you have to invest the capex for the MVR, and then of course, for example, for the solar panels on your roof, and then of course you have to again do the same thing. You have to make the calculation. Okay, what is my capex? What energy can I save? And what is my return on invest?
Yeah.
The game is always return on invest.
Yeah.
That's the game.
But I thought, though, again, because I'm just based on Dubai, surely with the infrastructure here of solar power already here, it would be easier. Or say Saudi, because Saudi is much more open coming, I think.
Of course, for you, it's you have so much energy, so that you can provide it to the electrical systems. So like the MVR, but of course, by the end of the day, for the customer itself, maybe it's not that good.
Yeah.
Because you'll say, hey, the energy is so cheap here. I can heat up my boiler like I did it 10 years before because the energy is so cheap.
Oh, so you think that it's the opposite thinking. It's not worth it.
Exactly. Yeah. Because if I can, let's take some numbers. Maybe it's easier to understand. I have a boiler and I do it the traditional way. So to evaporate 100 liters of milk, I have to pay 10 euro energy. So if I do now with this mechanical vapor recompression, so I have, because it's so cheap, it's the same amount of milk or what else, I have only pay 9 euro for the process.
Yeah.
So it's only 1 euro saving.
Yeah.
But the capex is around 100,000. So when is your return on invest?
Yeah.
So maybe it's like what you said, it's the opposite way, to have the cheap energy, that people are not interested in to optimize the process. It doesn't need to be MVR. There are many other projects or the processes which you can make an optimization.
Yeah.
But if you have cheap energy, why you should do it?
And that's the reason why I spoke about not just economical view on that. That's the reason why I said, hey, if the return on invest maybe is not there or is not that great as normal,
Yeah.
we have to answer still the question, what do we do?
Yeah.
Is it still good that we invest that kind of technical change
Yeah.
into that? So I don't want to speak about duty because don't put duty on in the industries. That's never that great, I think, from my opinion. But they have to answer it for themselves. Everybody has to answer it for himself, for the industries, and from the governmental view. I would push that.
Yeah.
Of course, I would do.
So I was thinking if you're going to be an industry leader, which UAE and Saudi are trying to do, it almost makes sense that they would do it anyhow.
Yeah,
If they're building it from scratch,
exactly.
why not just put it in?
Yeah, exactly.
You know,
Just do it.
just do it.
Just do it.
You know, like you're already in that scenario.
Exactly.
It's already. I just think it'd be so much easier.
Yeah.
Maybe the government also in Dubai or in Saudi. Let's talk about Saudi. Maybe the government should make some some benefits if you reduce your CO2 footprint, not to save energy, so also to save the CO2.
Yeah.
Because even if the energy is low here in Saudi, and it makes no sense, so I can take so much amount of energy, but they say no, you can do it, but if you also save it here, the energy consumption of your factory, then you can get some extra benefits.
Yeah.
Because the return on invest for the factory itself, it's not that worse. So he needs something, another piece of cake.
Yeah. Exactly.
So
It's interesting.
So it's all what kind of vision we have for the industries, for the nature, how to combine it to save energy, to save the nature. Yes. So this all comes to the vision. And again, this the question: how do we reach the goal of a net zero economy by 2050? This MVR is not the perfect solution for everything. It's just a small thing and a small step. Many more have to come. Many more.
But
This is the possibility.
it's a move in the right direction.
Exactly. It's the
Right. It's everything has a if everyone does their little part,
Yes, exactly.
then it all adds up.
Yes.
This goes into my last question here. Global adaptation. So, are there any specific regions or countries where MVR technology is gaining more traction? And what are the what are the driving factors for that region?
So what I see in the past 2 or 3 years, of course, countries are which countries are interested. Of course, countries are interested which have to pay huge amount of money for energy. So like Germany or even Europe the whole. And of course, I think that's on the one hand. And the other hand, to look globally is of course, where are the money? Where's the industry? And the industry is there, but because mostly this MVR application is for food and beverage.
Yeah.
So maybe 70% or 80%, something like this. And also all sewage plants, what Willi told us. So it's creating water or salt. It's for me it's also food and beverage. So where in which country are the most people? So where is this industry normally very strong? And is a countries in my point of view like India, maybe the Chinese. I know South America could also be. So I think this is there, of course, from the part of the human population.
Yeah.
And that will be the driver there, I think, because they get, of course, a bigger factory. For example, if you let's take again the milk farmer. The milk farmer in Germany is, of course, smaller than the milk farmer in India, because his market is huge, is more than in Germany, maybe 10 times.
Yeah.
So, of course, the industry there is also bigger than in Germany. So the factory itself, the company itself. And for them, of course, it makes more sense to make the mechanical vapor recompression because their saving are much higher. So it's typically like in every process, the bigger it is, the more efficiency it will get.
Sure.
So that's why it's not make sense to have something in your kitchen when you're cooking your pasta,
Yeah.
because it's too small,
Not worth it.
not worth it. And if you're like a company, I don't know, producing milk, and you are such a big company, then it makes sense for you to invest this money because your return is much higher. So I think these are the two drivers for this mechanical vapor recompression applications.
Lastly, where do you think, if we sit here in 15 years' time, where do you think MVR will be? What's the vision, the goal? What do you think the possibilities even? Even if I go back, let's say 20 years or 2050, so 25 years. If I went back 25 years ago, where we are now and where we are in 2050, do you think the technology will be so much more advanced? Do you think it'll be easier to implement? Do you think it'll be...
I think there will be many applications already installed, but I think also we as a company who producing the systems, and even our competitors, we will also create new possibilities and new techniques to also get better efficiency on our products. So of course that the energy you have to put for the machines, for example, is less than nowadays. So of course we will also work on it, because we see that's a huge market, also for the future. And so also I can say nearly the same thing like the person from India. My vision is also that we of course can implement where it fits the MVR technique to the companies, because by the end of the day, even like Willi said, the return don't make that sense. Maybe it's all 7-8 years. That's a long time for this, but also of course to reduce our energy consumption, and of course to reduce the CO2 emission.
Very good.
So it all comes with the vision we have.
Yeah.
And if somebody pushes the vision, the industries or the government, we will have a lot of more processes which we change. But if nobody is investing, and our view is changed because we didn't do it 50 years ago, nobody thought about that. And if nobody pushes that vision and pushes it with pressure, with money, incentives, or whatever, there is a high risk that nobody will do anything. So there has to be someone who pushes this idea. The industry by itself, because they have to save money, and maybe the government has to do a lot of homework, how they can push that in a really right way, not to put pressure on the companies that they say, oh, I will go out from that country, and that's what they are doing, because the production is much cheaper when I go to a different country.
Yes.
What did we win?
Yeah.
We didn't win anything. We just changed the market situation. So, and there maybe because the energy is very cheap there, but they don't think about nature. They don't think about
Energy, exactly.
Well, so if Germany starts, it doesn't make sense. Yes, we can be an example, maybe, but the industry will always follow the cheapest production. So we can do it just as a whole world. Really, it's impossible for a special region to do it.
Yeah.
The companies will leave. I'm guessing, yes. And that's what we are facing maybe nowadays in Germany. Many other reasons, I know. So we have to do it as a whole world to push that idea, to have that vision, not just one region. But it has to be in a good way, together with the industries, not with pressure, which is negative, and the industries run away.
Yeah.
So we have to have it very clear, together find solutions, incentive, whatever is needed. And we can, what I can do is I can change my private world, and buying stuff and driving an electric car, maybe it's really the solution or whatever, yes. So that's what I can do, and with my decision, I can also influence maybe the government or the industries, and everybody. If everybody would do that, we can change it together. So you can change it, I can change it, but together we can.
All together.
All together.
All the little things make one big thing.
Yes, exactly. That's what I would say, yeah.
Brilliant. Gentlemen, thank you so much for your time. I wish MVR very much success, and I'm very excited. Thank you so much today.
Thank you so much for you.